Hello, friends and listeners. We are proud to present today's guest, Mr. John Owen. Mr. John Owen was an accomplished computer science teacher at middle and high school levels for over 30 years. His students achieved high honors in state and national competitions, top scores on the computer science AP test, with many now working in the software development and various computer science industries. He served as a reader for 6 years on both A and AB versions of the computer science AP test. He is currently the computer science project manager for We Teach CS, a University of Texas CS education initiative, which he co-founded. Mr. Owen's recent efforts include development of an online first-year computer science curriculum for high school students called We Teach CS for high school, as well as the highly successful CS teacher certification prep online course, Foundations of Computer Science for Teachers, which is offered by the University of Texas at Austin for both Texas teachers and those preparing for the Praxis certification test used by many other states. This past spring, he and his development team completed and achieved full college board endorsement for We Teach APCSA, a curriculum designed to prepare students for the Computer Science AP test. In addition to this, Mr. Owen has served as an instructor for Oracle Academy's Java series of courses, Fundamentals, Programming Foundations, and was a facilitator for Code.org's New Discoveries curriculum. Mr. Owen's work has resulted in a significant increase in the number of teachers becoming certified in computer science throughout the state of Texas and beyond. He recently served for several years as the chairman of the State Competition Committee for Computer Science for the Texas University Interscholastic League, UIL. Wow. Mr. Owen, welcome. We are so excited to have you on our show. Let's talk computer science.
You bet. Thank you very much, Cindy.
That's beyond impressive. You have affected so many students, yourself, and so many teachers, and which is like the main issue that we have in our country, shortage of CS teachers. And
yes,
really impressive that you're addressing that issue, and through those teachers, many more students.
Yes, that is correct.
So tell us more about your work. How did you get to where you are today?
Well, it's an interesting story, and I love telling it because to me, my journey is replicated by many teachers these days. I'm not a computer scientist. I did not get a degree in computer science. In fact, I have a degree in music, a bachelor's and a master's, and I was a band director for 5 years. And decided to make a career change. And I started teaching math, algebra, and geometry at the middle school and the high school level. Went back and got my secondary mathematics certification in Texas. And then got a job at a high school in Northwest Houston called Cypress Creek High School, where there was already an established computer science program. And I had already been exploring using BASIC and the old Commodore 64 computer, which is now in the Smithsonian Institution, makes me kind of feel old. But I got in with them and they taught me the computer science that they taught to their students, and I was hooked. I said, this is what I want to teach. And so the main leader of that team, Marge Parker, she took me under her wing as my mentor and taught me everything that I needed to know. And I took the certification at that time. It was in the language Pascal, passed it, and got on the schedule for the next year to teach computer science and taught computer science the rest of my career, a total of 22 years in all. And I had a blast. And I was pretty good at it. I had a lot of success and established programs. And as you mentioned, my students did very, very well on the AP test and various competitions. But the main thing is that I taught students how to think with computer science. And my first statement to them, first day of class, is I'm not here to make you computer scientists. I'm here to improve your thinking capability. And regardless of what industry job you go into, you'll be able to use these skills to do that. And so I can relate to teachers who are, for whatever reason, either volunteering or being voluntold to teach computer science by their supervisors and their principals because they want to have computer science at the school. And as you alluded to earlier, that is the trend these days, computer science for all. But there are growing pains, and the biggest growing pain is the lack of teachers. And so that is what we are trying to address. We've done a really good job in Texas. We've had over 500 teachers since we started in 2015 become certified that we know of. And that's just through a program, an incentive program that we kept track of. Not to mention many other states that we've been working with, including Pennsylvania and Georgia and Indiana, just to name a few. So we're really pleased that we are having an impact, and we are pretty much one of the only players in the game of getting teachers certified. And so we're really proud of that fact.
Yeah. So everything that you've said, like it's so, I mean, so resonates with how what we think and what we hear from other guests. The computer science helps you think, not even if you don't stay in computer science, still it'll help.
Yes. Yes. Well, Jeanette Wing, as many people know, wrote an article back in 2006 in the ACM publication, and she basically attributed computational thinking as the fourth R. She didn't say it outright, but she said, just as the printing press enabled the three R's, reading, writing, and arithmetic, computers and computer science has enabled computational thinking. And that itself is almost a requirement. When Obama had his State of the Union address several years ago, and he said computer science is no longer an option, it needs to be a requirement. I stood up and danced to Jay. I said, that is exactly what we need to hear. So I'm really, really pleased that so many people are getting into that game and helping to support not just computer science teachers, but administrators. I was asked once, do administrators need to know something about computer science? And I said, absolutely yes. They may not have to be experts in it or be able to teach it, but they need to have the basic computational thinking skills so that they can solve problems and recognize the importance of their teachers and their students also needing to be able to solve those problems and use those computational thinking skills.
Yeah, and I'm so glad like you have co-founded We Teach CS. I know, we hear from so many places about how much you are like helping so many schools to become CS teachers certified.
Yeah.
So, not just in your state, as you said, like not just Texas. I hear a lot in Wisconsin as well, though you didn't mention Wisconsin.
Yes.
So, pretty much like all the universities that we talk to, they refer to you and they want to mimic what you're doing. But I hope they all get to the level what you are.
All they have to do is call us because we've got it down. We've got the program and we've shown success. To me, the biggest problem is getting teachers prepared to teach it, whatever that looks like in their area. Some states have a certification process, some don't. Some are trying to formulate that in whatever way that makes sense to them. And, there are some states, and I couldn't name them exactly, but they require a computer science degree to teach computer science. That's virtually unattainable for most teachers. They're not going to spend the time and the money to get a computer science degree. And you don't need a computer science degree to teach computer science. Computer science at the high school level, at least here in Texas, maybe reaches the first year and a half, possibly 2 years of a typical computer science education program at a college, at a university. And we give them that foundation. I used to tell my students, listen, when you go to the university and major in computer science, you're going to be bored to tears the first year and a half because you're going to already know this stuff. You're going to be able to just take the class and get an easy A, or you may be able to test out of the class, or if you have your AP scores and the college accepts AP scores, you're going to be able to get credit for that class without having to take it. But the high school level is where that training must happen. Number one, they need to be able to code. Now, of course, computer science is not just about coding. It's about design and computational thinking and breaking down problems. Much of software development, it happens before you get to the coding. You got to go through the design and development process. But if they don't know how to code, by the time they get to those college classes, they're already behind the 8 ball. They're just behind the curve, whatever analogy you want to think about. So our job is to train those students and get them ready for whatever college or higher learning experience they're going to do. If it's computer science, great. If it's something else, they now have the tools to learn how to problem solve, how to think abstractly, how to break things down in a top-down process and break it down into small solvable pieces that can put the whole project together.
Yep. Can you please talk about the different trends in the K-12 CS education? Are there any major changes?
Well, the biggest change, of course, is the CS for All movement. And we've been talking a little bit about that already, but that fuels pushing computer science, not just at the high school level, but down into the K-8 space, which I feel like is critical. Because if you can get computer science appropriately taught at the K-8, and it is possible, if you can do that, then that will just simply fuel the progress into the high school levels. And of course, another trend is including previously unincluded populations like girls and students of color who have not previously thought about computer science as something that they should go into. It's been primarily a white male society, and we need to break those stereotypes and those trends. And when I was teaching, especially when I started my first program from the very beginning at Rockport Fulton High School north of Corpus Christi, Texas, I intentionally went down to the middle schools and I talked to everybody, not just the guys, but the girls. And we had a large Vietnamese population there, and I talked to them. And that's not a part of their psyche. That's not a part of their normal upbringing. And many of the parents were immigrants. They were on fishing boats, shrimping boats. And it just wasn't a part of their thinking process to involve their students that way. And so it takes initiative and it takes inviting, especially those students. And it's important that you put into their minds the idea that they can do this, and they can if you support them. And I've had children of all colors and genders that go on and do great things. I had a student one time, beautiful, long blonde hair. She was on the drill team at the school, and her name was Kristen. And she, after about a week in class, she walked out, was going to her next class, and she was really frustrated. And she said, "Mr. Owen, I don't think this is for me. I don't get this. I'm really struggling. I guess it's just a blonde thing." And I stopped her right there. I said, "Kristen, give me another week. I promise you, you're going to find this something that you can do and do well." And she did. And she stuck around, and she ended up to be one of my best programmers that year. So it takes a cultivation process of convincing the students, not only can they do it, but they can do it well. There are so many hidden pools of talent out there that have not been tapped. And it takes inviting them and then providing a safe and risk-free environment, not risk-free, but an environment where they're willing to take the risk and not afraid to fail. That's the biggest roadblock towards getting these students going. They're so used to being perfect, or being expected to be perfect, that they are afraid to take the risk. And so I developed an environment where they weren't afraid to come in and take the risk and possibly fail because they kept going at it and they eventually achieved.
Yeah, that's a very good story. I really like that story, how the girl stayed and
Yes.
yeah, it's very important for
Oh,
girls.
it was a joy for me to finally say, look. And at the end of the year, I went up to her and says, look what you did. And she just smiled. She just grinned a huge, big smile. And of course, thanked me and said, thank you for making me stick it out. And that's what it takes, is you have to convince those students they can do it, and then cultivate that atmosphere of safety and to where they have the courage to take the risks. It's really important.
So you've touched on this a little bit already. Like, can you talk about the different paths for a teacher to be able to teach CS in Texas and other states?
Okay. I can speak directly to the ones who are in Texas. Simply, you just have to pass a certification test. If you are already certified in Texas as a teacher of some other subject, and you want to teach the computer science courses that require what we call the CS 8 through 12 certification, then you take the test. It's called the 241 TEXES test. And once you pass that test, then you just send it in, you add it to your certification, and you're ready to teach it. Some other states use the Praxis test, which is a similar test in many ways, which we also have defined, of course, the foundations course. Remember in your introduction, you said for both Texas schools and for Praxis schools, many of them are using that instrument. And so if they take that, then they have a pathway to certification. And it just takes training those teachers and convincing them that they can do it. Now, I will say this, those two tests, I've taken both and I've passed both. You might wonder, how did I take the Praxis test if I wasn't in another state? Well, I was able to get into another state's portal and sign up. I won't tell you what state it was, but I did, and I passed it, mainly because I wanted to experience what those teachers would have to experience. And I can tell you, those two tests are two of the hardest tests I have ever experienced. They are tough. They are rigorous. But I have personally met with the writer of that test. And that person is a sharp cookie. And she does a great job of writing questions that are meaningful and rigorous and valid and reliable and test the true nature of what a computer science teacher needs to know. So I believe that both tests are valid. Pearson has several versions that have been used in the past by various states. Ohio, I know for sure. Indiana was using one. Now they have moved over to the Praxis test. Georgia uses a version of the Praxis test. They call it something different, but it's essentially that. And as I said earlier, many states are trying to find their way there. And more are getting on board with the idea of if they can pass the test and they're already certified in something else, they can just add that certification.
Okay, so how similar or how different are this Praxis test versus the Texas?
That's a really good question. There is an overlap, and I've studied both of them and I've done crosswalks between the two. And there's about a 70% overlap between the two, and the core that's, imagine the Venn diagram, you've got the circles. The overlapping part of that circle is all of the code-based, the data structures, the processes, the constructs, variables and loops and if-else statements and that kind of stuff. All of the code-based stuff, those are common. Now, there are some fringe things. For example, Texas has some tech apps that is not really computer science, but it was under the tech apps umbrella. And so they required that a portion of the test be tech apps, things like word processing and spreadsheets and that sort of thing. That's using applications. That's not developing applications. And so, and then the Praxis test, they have a whole section called impacts of computing and another section called computers and networking, where it's talking about non-code-based aspects. And so the two courses that we've done have been tailored towards that particular set, the Praxis towards their set, the Texas towards their set, and there's just a lot of commonality in between.
That's good information. So can you please give your suggestions or opinion on how should schools increase CS education?
The biggest problem towards getting more students into computer science is finding the teachers to do it. We had a survey of superintendents all in Texas when we were first getting started, and that was their number one need. We would ask them the question, why don't you have computer science at your school or in your district? And they said, we can't find teachers. So that is the biggest problem. The demand for teachers and the supply of teachers there's a huge disparity. And so that is where we decided to focus our attention. And as we've talked about already, that has been a big impact. The number of people involved, the number of programs and schools involved, and then now students enrolled, as well as diversity enrolled, has increased because the teacher supply increased. That's where the rubber hits the road. You have to have teachers. Now, you need to be careful. If you are a state that says, okay, we're going to have CS for all, then you better be able to find teachers to do it. Because if you require something and you don't have the teachers, you don't have the supply to back it up, and you force teachers into doing that, then you could have a backlash and an outcry. So it's a balancing act. Do I feel like computer science should be required for every student? Yes. If they are going on into a higher learning situation, then they need to have at least 1 year of computer science. Are there some states or even countries who require that? Yes, there are. But it still has problems. And it's going to be growing pains for a long time until we increase and give sufficient supply of teachers. So we have to support teachers. Now, there are 3 sources of teachers. 1, existing teachers. 2, college students coming out that have computer science training, either a degree or maybe they are in a pre-service program to where computer science is their emphasis for teaching. And 3, industry professionals who have decided they want to change and they want to give back for whatever reason. Microsoft has a great program called TEALS, where they involve industry professionals in mentoring teachers. And that's a whole nother hour. You could have a discussion about somebody from TEALS. But those are the 3 main sources. Now, is it likely that somebody from somebody from the college who gets a computer science degree, is it likely that they're going to go teach? No. They're going to go where the money is. They're going to get a job. Now, we've had some instances of that where they come to teaching and either stay, or they come to teaching for a couple of years and then they decide to go get their job. Are there industry professionals that will come down and do that? Yes, we have a good sampling of that. But neither one of those solutions is scalable. Neither one. There's not going to be a big enough supply. The biggest supply is current teachers. Somebody who's teaching kindergarten or a middle school librarian. And we have instances of both of those. A teacher who is ready for a change. Maybe they're bored with what they're teaching. Maybe they're disenchanted for some reason. They want a new challenge. Whatever the reason, that's where we have to go, is current teachers. And so that's the key. That's the secret.
I know, like, We Teach CS has built many resources to teach CS. Can you talk about any other kind of resources out there to teach CS for K-12 schools?
Well, just to summarize what we have, and then I'll talk about some others. We have 2 training courses for teachers, and we have 2 curriculum packages for teachers to use in their classrooms. One of the first things I told my team when we first started We Teach CS, I said, there's 2 steps to this process. You need to get teachers certified, have their learning base strong enough to where they can pass the test and they can get their certification, but then get them through the first year or the first 2 years. There are not a whole lot of really good curriculum packages out there. There are a few, and some people use them, and that's great. but we feel very strongly, and mine are based on the development that I did over many years, because I kept looking for good curriculum. College textbooks just don't work at the high school level, in my experience. And so we developed something that works. We know it works because I've tried it. And our AP curriculum, we've piloted for a couple of years now, and teachers swear by it. The kids love it. We use an online platform. So certification features and curriculum, that's what we do. That's what we have. Now, another strong leader, especially in the K through 8 space, and recently in the CSP space, is code.org. We are a regional partner with code.org. We started out in the Austin area, and we've gradually expanded, and now we manage the entire state of Texas for all of the code.org initiatives. And their fundamentals and their discoveries and their principles programs, elementary, middle school, and high school, are very, very good at getting schools involved. And that's where the K through 8 process gets into play. And a lot of schools have had a lot of good success with that. And then the principles course is a great course for kids who just want to see what computer science is like, may not be into the hardcore computer science, but at least it's something that they can do. And many of the colleges that pioneered that are offering a similar course at their level, Berkeley and Harvard and many others that have done that. And so that really is the key. And those are great programs. I can name many others, but I would say code.org is probably the leader in providing free, available resources for teachers to use with their students.
Thank you for sharing those resources.
Sure.
So what are the ideal solutions for resources that are needed to help improve or increase CS education?
As I just mentioned, training for teachers and meaningful and usable curriculum for those teachers to use with their students. Those are the key things. In my experience, with not just doing my own work, but in mentoring other teachers, as I was in my area of teaching, I would help teachers from neighboring school districts. That was the big thing that they always fought and always struggled with, is finding suitable materials. Okay, the programming language is not as important as good curriculum to support it. So you might start in Scratch, or you might go to use Alice, or there's another programming language that I use called Jeroo, Jeroo. It's not as well known, but it's a fabulous programming learning environment. There's Carl the Robot. And then, of course, there are scripted languages like JavaScript, which is the backbone of what code.org uses with their block-based program. There's Python, which is an excellent first-year learning and even eventually a professional level programming platform. And of course, Java is what the AP course is based on. And there are any number of resources that can support any of those languages.
Thank you so much for sharing all of this with me and our listeners. And thank you so much for doing everything that you have done so far for education and especially computer science, and through We Teach CS.
Thank you very much for having me.
Anything else that you would like to add, John?
I would just say that if you know someone, or if you are someone who are ready for a challenge and you want to look into We Teach CS or into computer science teaching in general, there are resources out there. WeTeachCS.org is a great place to start. And we have lots of resources and lots of information. And we feel like we have given the solution, provided the solution for not just teachers, but administrators who are trying to build their programs, legislators who are trying to find solutions for their state. It's something that can be done. It's not easy necessarily, but it can be done because we have proven it here in Texas, and we are happy to share our success and everything that we've learned with anybody else who's interested.
Thank you, John. Thank you so much for your services and for your
Thank you.
Today.
Thanks for having me.